So we are starting off on question 16. So a water glass can be modeled by a truncated right cone, which is a cone which is cut parallel to its base, as shown below. The diameter of the top of the glass is 3 inches. Okay, so the diameter is 3 inches. And the diameter of the bottom glass is 2 inches. And the height of the glass is 5 inches. The base with the diameter of 2 inches must be parallel to the base with the diameter of 3 inches in order to find the height of the cone. You have to explain why. All right, so we talked about truncated cones in the volume unit, and now it's obviously been a while since then. But to find the volume of this, we would need to do the volume of large cone minus the volume of the small cone. And that's going to give you the volume of the truncated right cone. Okay. Now, in order to find the heights of these cones, the heights of the small cone and the heights of the large cone, we would need to set up a proportion to find, because these are similar triangles, to find the heights. Okay. Now, these have to be parallel because these have to be similar triangles. Okay. So in order to find the heights, you need similar triangles in order to set up and solve a proportion. Okay. Now, this question's cut off. This is like a 4-point or kind of a more harder question on the Regents. Now we cut it off, but just for review, let's go over about how to solve for the volume of the truncated cone. All right. So, like I said, this is a triangle and this is a triangle. They are similar. Okay. So, in my formula here, the volume of the truncated cone is the volume of the large cone minus the volume of the small cone. Now, in order to find the volume of a cone, you need to know the height of the cone. All right, so we need to solve for the height of the cone. So we're going to call this x is the height of the small cone. Now the height of the large cone is 5 plus x, or x plus 5. Now the ratio of the height, the large height and the small height is equal to the large radius over the small radius. Okay, so this is the diameter, so the large radius is 1.5 and the small radius is just 1. Okay, so cross multiply, so x plus 5 is equal to 1.5x. All right, so now we subtract x, so 5 is equal to 0.5x. Now divide and solve for x, so x is equal to 10. Okay, so the height of the small cone is 10 and the height of the large cone is 15. All right, so we're going to use these numbers and our radius and plug them in to solve for the volume of the truncated cone. All right, so let's find the volume of the large cone. So volume of large cone, so 1/3 pi, the radius is 1.5 squared times the height is 15. Okay, minus the volume of the small cone. So 1/3 pi 1 squared times the height, which is 10. Okay, now we're just going to plug this into our calculators. So 1/3 pi squared times 15 So 35.34291735 minus 1/3 pi squared times 10, which is minus 10.5471975551. Now to find the volume of the truncated cone, we have to subtract these. So we're going to do volume of large cone minus this. So volume of truncated cone is equal to 24.87094184. We're going to round it to the nearest tenth. Obviously, there's no direction, so let's round it to the nearest tenth. 0.9 inches cubed. All right. So that is to find the volume of a truncated cone. All right, so let's go to 17. So if the volume of a cube is 8 cubic centimeters, what is its surface area in square centimeters? Okay, so surface area. All right, so surface area is the area of the faces in a 3D shape. Okay, so it's on the outer parts of the shape. So let's talk about 17. So if the volume of a cube is 8 cubic centimeters, what is its surface area in square centimeters? All right, so first of all, we need to find the length, we need to find the height, and we need to find the width. All right. So we have a cube. Now the volume is this, and the cube, the length, the width, and the height of a cube is all the same. So to find we're just going to call it x. To find the volume, we're going to take the cubed root of both sides. So 2 is equal. So 2 is the height, it's the length, and it's the width. Okay. Now our formula for surface area for a cube is this. So 2 times length times width plus length times height plus height times width. Okay. So our height, our length, and our width. And our length is 2 and our width is 2, so 2 times 2 is 4. Length is 2 and our height is 2, so this is 4. Plus height times width is 4. So 2 times 12. So our surface area is 24 centimeters squared. Okay. All right, let's go to number 18. So the base of a closed right circular cylinder has a diameter of 5 centimeters. Okay. So it has a diameter of 5 centimeters. If the height of the cylinder is 8 centimeters, what is the surface area of the cylinder to the nearest square centimeter? All right, so the surface area of a cylinder is 2 pi r times r plus the height. So the radius plus the height. Okay. So now let's plug this stuff in. So surface area is equal to 2 pi. Now the radius is 5. So that's 2, our radius is 2 point, our diameter, sorry, my diameter is 5, so my radius is 2.5. 2.5 plus the height is 8. So 2 pi 2.5 times 10.5. All right, so let's plug this stuff in. So we have 2 pi times 2.5 times 10.5. So surface area is equal to 164.9336143. All right, so the nearest square centimeter. So our answer is number 2. Okay. So while we're thinking of this right now, let's write down these formulas on the front of your paper. All right, it'd be a good thing to write down. All right, so surface area for a cube is 2 times length times width plus length times height plus height times width. Okay, so that's the surface area of the cube. Surface area of cylinder is 2 pi r times r plus h. Okay. All right, so let's go on to the next question. Now let's go to 19. So as shown in the diagram below, the diagonals of parallelogram QRST intersect at E. If QE is equal to x squared plus 6x, SE is equal to x plus 14, and TE is equal to 6x minus 1, we want to determine TE algebraically. Okay. So first of all, this is a parallelogram. Now diagonals bisect a parallelogram, but here's the thing. This is congruent to this, and this is congruent to this. Okay, so we have to be careful. These two are not equal to each other. Okay, so QE is equal to ES, and TE is equal to ER. Okay. So first of all, before we can find TE, we have to solve for x. All right, so x squared plus 6x is equal to x plus 14. Okay, so this is a quadratic because it has an x squared, so we have to get our equation equal to 0. So we're going to subtract x and subtract 14, both sides. So we have x squared plus 5x minus 14 is equal to 0. Okay, now, like I showed you the other video, I think at some point, if you don't know how to solve a quadratic, like factoring or anything, go to your y equals and put it in your y equals. Okay, so table. All right, so we're gonna have to find where y is 0. And those are your solutions. So 2, so x is equal to 2. And that is it, because here's the thing, you can't have a negative. So the x is equal to -7, we cross that out. All right. All right, so now let's take our x value and plug it into our expression. So 6 times 2 minus 1. Because we're finding the length of TE. So 12 minus 1 is equal to 11. So the length of TE is equal to 11. Okay. All right, so let's take a look at 20, but before we do that, sorry, this is kind of faded. Now, hypothetically, if you were given a triangle that is not a right triangle, and all you were given is the sides of the triangle, and they wanted you to find the area, okay? And now instead of finding the height, this is the formula that you could use to find the area of a non-right triangle, not using coordinates. Because remember, if we have a graph and we had a triangle in the coordinate grid, we could do the box, right? You could find the area of the rectangle and then subtract. This is not the greatest example for that, but we could find those, find the area using like subtraction, finding the area of the rectangle and finding the area of those smaller pieces of the triangle in the rectangle, and then finding the area of the triangle that we need to find. But here's the thing, obviously we have no coordinates, so that doesn't work here. Okay, so this is the Huron's formula. Now let me rewrite it so you guys can see it, because it's kind of hard to see. So area is equal to the square root of s times s minus a times s minus b times s minus c. Okay, now s is just equal to the average of the sides. So the side A plus the length of side B plus the length of side C divided by 2. Well, I guess it's not the average, but kind of that idea. Okay, so let's take a look at an example. So the accompanying diagram shows a triangular plot of lands located in Moira's garden. We want to find the area of the plot of land and round our answer to the nearest 100 square feet. Okay, so we're gonna call this side A, side B. No, we're not gonna do that because remember our sides are across from our angle, so side A, side B, and side C. Okay, so first of all, we need to find S. So we need to add up all of these numbers and divide by 2. So 125 plus 160 plus 135 divided by 2. Okay. So S is equal to 210 Okay, so we're just going to plug these numbers into our formula here. So our first number is S, so this 210 is going to go here, times 210 minus side A, which is 160, times S again, 210 minus side B, which is 135, times S again, 210 minus side C, which is 125. Okay. Now we're just going to put all of this in our calculator. So 210 times 210 minus 160 times 210 minus 135 times 210 minus 125. Okay, so our area of our garden is a 1.534086. Okay. Our area is equal to so I think it says the nearest 100 square feet, so 8181.53 feet squared. Okay. All right, so we're gonna do one more and that will be it for this video. Well, maybe not, we'll do a couple more. Okay. All right, number 21. The transformation of angle ABC to angle AB' C' is shown in the accompanying diagram. This transformation is an example of a what? Now, a lot of you, I guarantee you, are going to look at that and say, this is a reflection. But it is not a reflection. I'll tell you why. B has to map to B, or B prime has to map to B. C has to map to C prime. Now, if this was a reflection, C would end up over, C prime would be over here, and B prime would be over here. That is obviously not the case, okay? So do not say this is a reflection. This is obviously not a dilation, and this isn't a translation, okay? So it's a rotation about point A. We have to be super, super careful that you don't confuse rotation with reflection, all right? I'm going to skip over 22 and I'm going to go to number 23. We'll come back to 22. Okay. So a flagpole casts a shadow of 16.6 meters long. All right, so let's draw our flagpole. Okay, now a shadow is on the ground. So this whole thing is 16.6. Tim stands at a distance, here's Tim, at a distance of 12.45 meters from the base of the flagpole, such that the end of Tim's shadow meets the end of the flagpole's shadow. So Tim is 1.6 meters tall, 6.5 meters tall. We want to determine and state the height of the flagpole to the nearest tenth of a meter. Okay. Now this is a weird question because we're used to drawing these diagrams and being SOHCAHTOA, but it's not SOHCAHTOA. It is a similar triangle proportions question. Okay. Now if you take a look, this is one triangle, and this is the other triangle. Okay. So here's Tim's triangle. Now again, if similar triangles and proportions confuse you, separate them. Okay, so 1.65, 16.6 minus 12.45. Now this, we have to find this. This little part is equal to this minus this. So we have to do 16.6 minus 12.45 to find this little part, which is 4.15. Okay. Now we have our big flagpole triangle. So this is X, this is 16.6. Okay. So to find the height of the flagpole, we solve for X. We set up a proportion, solve for X. So this is 1.65 over X is equal to 4.15 over 16.6. Okay, so now cross multiply. 4.15x is equal to 1.65 times 16.6, which is 27.39. If we divide by 4.15, so x is equal to 4.15, which is 6.6. So the height of the flagpole is 6.6 meters. All right, so that is going to be it for today's video. All right, so tomorrow there'll be another video that you will watch. All right, so keep working hard.